currently I'm working in AI team. My research field is computer vision, and I had some experiment with the computer vision. So today I will bring to you the popular problem when we're working with the applied machine learning to work with the image. So we are to try with the problem is handwritten. This is for classification. So you can look at it. We have with the data set. The data set is MNIST database, so the data is provided from the professor at Facebook AI. So in the data set we have about 60,000 images for data. So you can look into the structure and set of data. We have 60,000 image for training and 10,000 image for testing. So I will doing the next step is how can we do the apply machine learning to solve the problem for this. The first thing we need to understand about exactly the structure of data and how we can pre-process the data before we use machine learning. So in the structure of data, we can see we have the image with the size is 28 multiplied 28, and the data has one channel. The image is recount, and we have the data coming from the 0 to 96. So to making the preprocessing, I just flatten the image into the vector one dimension. Currently, the image has two dimensions because we have width and height. So I just flatten this, and we can see we have the vectors about 784 dimensions by multiply 28 plus 28. Okay. So when we look into the step of the data train, so now we have the 60,000 and 784 and 10,784. It's different with the previous data. In the raw data, we have the set different because we not preprocessing. So after we change the image into the array 1D, so the next step is we use the normalize. We know the each of pixel in image come from the value come from 0 to 255, and so for normalize it, we just divide all of the value to 255, and we get the data of the image come from 0 to 1. This is the normalization data. So the classification process in here, I will show you some algorithm in the machine learning, support vector machine, decision tree, k-nearest neighbor, and the last is softmax classification. Okay, and now we can look into the simple code of this. I just use the programming language of Python and use the scikit-learn library for the machine learning support. They will implement a lot of machine learning model, and we can use it based on the API. Just we have two functions in here. So we have a fixed function and predict functions. Fixed function, we just put the training data output of the fixed function in the model, and if we can use the output of the fixed function in the model to predict the test data to get the evaluation of the result. So you can see the accuracy when I'm using the k-nearest neighbor algorithm is 97%. And the next algorithm is support vector machine algorithm. This is the popular machine learning models in the world. This will apply in a lot of fields. So in this model, you can see we can get the accuracy about 91%. It's quite good. And the next is decision trees. Yes. Now you have to look into the simple code. You will see we just have two functions, fixed and predict. For our three algorithm, we don't know exactly what algorithm we use. We just know fixed and predict function. Yes. Okay. And for the decision trees, we get the accuracy 88%. So I think it's not good for this problem. So I will come to show you the visualize the result in the test sample. So we see we have some wrong data for the predict. The bot had the color red is wrong. The predict model is wrong. So that's all of things we can do with machine learning. So in another approach, I will show you a little bit about how we can improve the machine learning model. The way I improve the machine learning model, I use deep learning. This is another approach. I will build the simple neural network, just simple. The simple neural network I just put with the 12 fully connected layer. I will start and put it together, and so you will see the simple code. It's just the way I build the neural networks. So simple. And after I build the network, I try to push the data word preprocessed into the fixed function. Yeah. In the framework support for the deep learning and machine learning function. For the machine learning, we still have two functions, fixed and predict. And after I'm to fit the function into the data into the model, you will see I will training the neural network with 10 epochs, and I get the accuracy about 98%. And so this is the result of deep learning model. I think all of the testing is correct. So that's the only thing I would like to share with you.